Enterprising Birmingham celebrates the culture of innovation at the University of Birmingham. It's a really important initiative that we run because we're trying to identify enterprising researchers who have developed commercial opportunity based on their research. The innovations that are showcased aren't just an example of the brilliant ideas that our academic community is working on, or the significant potential that our research can have on society. With a bit of training and support from our Department of Enterprise and Innovation, they also show how academics can start to think of their innovations and ideas from the point of view of potential end users and customers. They can start to visualise how people might use products and services based on these innovations. It's that change of thinking which can really help them go on to make impact. Our Most Innovative Collaboration Award recognises projects in which academics are really engaging and working with an external partner. These partners can vary from commercial businesses, social enterprises, charities, to government or public sector organisations. The ones that this competition has sought out are those in which the benefit to each partner and to society have the potential to be so much greater than the sum of each partner's contribution. This is Enterprising Birmingham.
Antimicrobial resistance is something that's becoming a very big global challenge.
So by 2050, it's estimated upwards of 10 million people will actually die because of antimicrobial resistance.
At the moment, there aren't any short-term solutions to this problem. There are lots of people working on alternatives.
Our project has recently been identified and featured as one of the top 10 most innovative collaborations that is likely to go on and change the world. This is because it has massive potential in terms of actually saving people's lives globally.
Surgery Honey is a product that's already on the market. The company Matoke Holdings came to us with quite a unique problem. What we're trying to do is expand its applicability so that it can help in a number of different kind of clinical situations.
The beauty about this project is that we're actually taking a product which has been around for thousands of years. Honey is found in most people's homes, and what we're doing is we're breaking it down and finding out exactly what is causing that antimicrobial effect, and we're delivering that as a solution so that we're able to kill bacteria.
The issue currently with the product is that it's difficult for clinicians to handle. It's very viscous, it's quite sticky, and really that's where we come in. So our job is to formulate new physical forms of the product to make it easier for a clinician to apply it to, whether that be topically or whether that be to other parts of the body to help kill infections. I think Birmingham's a great environment for healthcare research, and really what that institute's aim is to enable people like ourselves to bring products to market as quickly as possible. The market potential for this is very, very broad. Antimicrobial resistance is currently costing the NHS around £180 million a year, and it's killing roughly 3,000 people just in the UK.
I think come 2050, if I can look back and see that I've actually produced a product that has managed to help save people's lives, that would just be absolutely amazing.
There are currently 1.2 billion people who live in areas of poor sanitation. Millions of people a year have died from waterborne diseases. I'm an environmental scientist with a particular interest in human impacts on freshwater systems. We have developed a sensor that can provide a real-time indication of the amount of organic pollution in rivers, and can be used by environmental legislators and also by industry to monitor their discharges into natural river systems.
And what we can do with this technology is monitor the water environment in real time, and we can see how river water quality changes during events.
So I'm the Managing Director of RS Hydro, and we specialise in flow, level, water quality, and we were lucky enough to have Birmingham on our doorstep. Birmingham University is a fantastic university. The actual instrument itself, it's got everyone talking in the industries that it would be used. It's a classic example of disruptive technology.
The project is a potential game changer because we can track the interaction between natural drainage pathways and the storm sewage system. There are many different research applications that enable us to analyse as environmental researchers.
The opportunities we're getting already, and it's still quite early days, are on a global scale. It's allowed us to talk to new companies, big companies that possibly would have just laughed us out the door.
It's enabled them to start to expand, and they're looking to produce the sensor themselves and have assembly locally.
Well, ultimately, as a company, it's going to give us a massive business opportunity, so there's no doubt that jobs will follow.
And we also would be keen to explore the utility of the sensor for monitoring drinking waters, as this has obviously real world applications.
Why is it important? Would you like to drink dirty water? We need to have confidence in the environment that we live in. We need to be able to understand what the effects of change in the environment are.
And this technology has the potential to saving lives.
Birmingham has turned into one of the highest crime rates cities in the country, and young people are near the top of that list, I would assume. We work with 16 to 25-year-old young people. We started off in the church, and from the church now we've got other projects all based around the city for our young people. Reduce homelessness is our main object.
I'm a sports psychologist by training, and we use the same techniques that would normally be applied in a sports setting to enhance performance for world-class athletes. And we're taking these same principles and using them with young people who are homeless to help them to not just get back on their feet, but really thrive and build independent lives for themselves and go on to be successful in their own right. So the collaboration with St. Basil's came about a couple of years ago when we were in contact with them, and they asked us this intriguing question: can sports psychology work for homeless young people? We really believe that the mental skills that an athlete uses under pressure to maintain their confidence and their motivation can be used for anyone. So we took this challenge on board, and we've been working with them for the last 3 years to now develop a program that's being delivered to over 300 young people.
It's giving staff better tools as well, how to work with the young people. So for the university to come in and show us some of their tools that we're using and to implement that on our young people, I personally have seen a difference with some of our harder to reach young people. With the skills that we're giving these young people, we're definitely keeping them away from the dangers of life, like your drugs, your drink, your alcohol abuse, sexploitation.
If they can climb a mountain, they can go off and get that job, they can go off to college and be successful. The cost of homelessness right now for 16 to 25-year-olds in the UK is estimated to be £2 billion. We're going to be able to have more effective ways of working, be able to improve outcomes at such a low cost. The benefits are for everyone.
Cardiovascular disease is the second biggest killer outside of cancer. Thankfully, we're finding more and more ways to deal with cardiovascular disease, better understanding why it happens, better ways to understand the drugs that people use and how they work. For example, one of the techniques that has revolutionised the field recently is optical mapping, which is this fantastic technique where you can look at really detailed maps of the heart and its electrical activity. The problem with it is the images we get from optical mapping data often are poor signal quality, they're a bit messy. So what our project does is hopefully unify this field and sort of give everyone sort of a basic platform to which to best make use of optical mapping data.
It's going to enable faster, quicker and easier processing of the dataset, which would help in understanding how the heart electrophysiology is working.
So for the NHS, we believe it would simply just give them confidence in the drugs they're using, that electrophysiologically it's working how they expect, and they can give it to a patient in full knowledge that we know what it's going to do to their heart.
It is a very interesting prospect in terms of developing an area of research that is actually not covered by a good solution at the moment in terms of equipment and software.
And going into future, we would be looking to work with more illuminators, the LED illuminators that shine the light, more kind of cameras that acquire the images, higher resolution images, so that we can get more information of the heart and give more interpretation of whatever is going on inside.
Ultimately, this software and a better understanding of how the heart beats, it will hopefully enable, by allowing loads of researchers to get into this field, will ultimately deliver efficiencies for the NHS, deliver efficiencies in the drugs we use to deal with heart disease.
This software will translate into saving lives.